So today we are going to uh, find out the solution for a problem that is finding two elements such that their sum is closest to zero. So in today's assignment, the contents are going to be initially we are going to understand the problem given problem statement, and later on we see how we are going to approach the solution, followed by its pseudocode and its data structure. Then we'll go ahead and provide the code for the problem, and further we look into the possible edge cases and its efficiency, finally concluding with our solution. So understanding the problem statement. So here we have given the two positive list of two positive and negative integers, wherein we have to find the closest element whose sum is closest to zero, not necessarily a zero. So if we have an input list of numbers, so out of those integers we have to find the output wherein the closest sum is zero. So for this particular problem, let's see how we can approach. So in this particular problem, we can use a function called find closest sum pair that tackles the problem of finding the two elements in a list whose sum is closest to zero. So here is the breakdown. So first part is initializing, wherein the function that we have mentioned initializes several variables. For example, starting with the left and right pointers to iterate through the sorted list, that is starting at the beginning and the end respectively, followed by the closest sum, wherein it stores the current minimum absolute difference between a sum and zero, which is actually initialized to positive infinity, followed by the best pair, wherein it stores the two elements with the closest sum. Initially, it will be empty. Further, we also use a two pointer technique, wherein the core logic lies in a while loop that continues as long as left is less than right. Further, if we see inside the loop, the current sum is calculated by adding the elements at the indices left and right, and also the absolute value of current sum is compared to the closest sum, and the corresponding element at indices left and right are stored in best pair as current closest pair. And this is our pseudocode. If we see our pseudocode, we can see that initially we are sorting the list of number, that is to enable the effective two pointer search, and also we are doing a two pointer initialization so that the two pointers are set, one at the start to the left and one at the end to the right of the sorted list. And further we have to do the loop and condition checks. While the left pointer is less than the right pointer, the sum of the elements at each pointers is calculated and compared against the closest sum so far. So if the current sum is closest to zero, then we can update the closest sum and the best pair to current sum, current uh, current sum, closest sum and best pair. Current sum is closest. We can update the closest sum and the best pair. Also, we can adjust the pointers depending on whether the current sum is greater than or less than or exactly a zero. So if the sum is greater than zero, decrease it by moving right pointer to the left, Also, if the sum is less than 0, you can increase it by moving the left pointer to the right. If the sum is exactly 0, then it's an optimal solution. So the pair is returned immediately. So we can provide a return statement. So after exiting the loop, return the pair that has closest sum to 0. So this will be the pseudocode and how it is designed. So further, to see the data structure of the pseudocode, so in data structure, initially we use input list. This is the primary data structure and that contain list of integer for which we need to find the closest sum to 0. And then we use the pointer, left and right pointers. So these are integer variables used to iterate through the numbers list using the two pointer technique, wherein left starts at the beginning of the list, that is index 0, and right starts at the end of the list, wherein the index of the last element. Then we use closest sum, and this is also a floating point variable like how it is in Python. And so it is initialized to positive infinity, and it stores the current minimum absolute difference between a sum and 0 pair. This can be a tuple or a list containing two integer element, that is for the best pair. So it is initialized to null or an empty list or tuple, and it represents no pair found initially. And this best pair is updated throughout the loop to store the two elements with current sum to the 0. This is our data structure, and this is our code for the problem. So we can, from the code snippet, we can see how the data structure is followed, and how the closest sum and best pairs are initiated, and how the left and right pointers, or how the left and right pointers of the, or to the index 0 and also to the index of the last element. So since we have gone through the code, since we have written the code, there might be a possibility that there are edge cases that may occur in the code. So basically there are two with regards to this code, that is which may occur in the code, that is empty list and single element list. However, if we see the code that we provided uses a, we use a two point technique that actually efficiently iterates through the sorted list, making those specific edge cases irrelevant in this context. So both empty list and single elemental lists become irrelevant as we are using a two pointer technique. And also this two pointer approach, left and right, actually if we in that in that code, it don't even enter the main loop, while, so in these cases it actually prevent errors. So we can assure that there will be no empty list or single element list will occur in this particular code. Let's see the efficiency of this particular code for the problem. So if we see, when it comes to time complexity, actually in our code it first sorts the list using sorting algorithm like quick sort or merge sort. So these algorithms have an average and worst case time complexity of 0 of n log n, where we can take n as the number of elements in the list. And also if we see the two pointer loop, the two pointer loop iterates through the sorted list at most n times, once for each element. In each iteration, the constant time operation like addition, comparison, and point movement occur. So if we see the overall time complexity, the sorting step dominates the time complexity due to its zero of n log n nature, and the two-pointer loop contributes a linear factor 0 of n, but in less significant compared to sorting. So therefore, the overall time complexity of the code is 0 of n log n. Coming to the space complexity, the sorting algorithm might use additional spaces for temporary storage during the sorting process. Even in the worst case, the space complexity can be 0 of n depending on the specific sorting algorithm used. uh, Maybe if we can see, for example, quicksort uses recursion, so which can require extra space for call stack. And if you see, the two pointer technique itself uses constant extra space for the variables such as the closest sum pair and also the left and right pointers. So so what we can conclude is that this provided code offers an efficient solution with the time complexity of 0 of n log n for finding the closest sum 0. Also, the sorting step contributes the most significant factor to time complexity. So, I would like to conclude with saying that in this presentation, we have explored an efficient approach to find two elements in a list whose sum is closest to 0. Also, the function the find closest sum pair utilizes a two-pointer technique to iterate through a sorted list efficiently, finding the elements with the closest sum. Further, the presented solution effectively finds the closest sum to 0 in a list, demonstrating efficient use of sorting and two-pointer techniques. Thank you. Thank you very much.